Today we're going to begin the next chapter. We're only doing two sections, 6.1 and 6.2. And then we're in ingenuity after that. So I'm going to start 6.1 today. This assignment will not be due till Monday because you're going to need to be preparing for the test on Friday. So but I want to go ahead and get this out there so you have it ready for Monday. All right. So the vocabulary and the notes, you don't have the graphic organizers. If anyone would like to have graphic organizers, like if you have access to a printer and you would like that, just simply email me and I'll send it to you privately. All right, so the first word is oblique triangle. Oblique triangle is a triangle that is not a right triangle. A triangle that is not a right triangle. So far, we have used trigonometry to solve right triangles. Well, guess what? We can use trigonometry to solve oblique triangles. Now, we still want to label the sides the same way we labeled a right triangle. If possible, let's see, lowercase c. Here, I think I'll put that over here. Lowercase c is the side opposite the angle that is c. And b, opposite the angle, is lowercase b, and a is a. So we still label them the same way we did a right triangle. Typically, we like to make a the smallest, b the middle side, and c the longest side, but it doesn't always end up happening that way. So don't worry about it if it doesn't end up happening that way. That sometimes happens, okay? So we're gonna solve this. Well, to solve this, we're gonna use, if we're gonna start the notes now, that's the vocabulary. So this is notes 6.1. If you want to just put that on a piece of notebook paper, we're going to use the law of sines, to solve an oblique triangle. Okay? So the law of sines is A over sine A. So it's the side opposite the angle A, okay, equals B over sine B equals C over sine C. It's called the law of sines. Alrighty, now just kind of so you know, this is the rule that is in our textbook, but many textbooks do these reciprocals. They put sine A over A, sine B over B, sine C over C. So technically it doesn't matter as long as you're consistent. All the side lengths on top, all the sine of angles on the bottom. All right? Okay. One thing also is that you will want to be, for triangles, just to remind you, I think you already know this, but you will need to be in degree mode. As we've talked about before, triangles are only measured, just a plain old triangle, not in the unit circle, just a random triangle. This is always solved with degrees, not with radians for angles in a triangle, whether it's right or oblique, okay? All right, so let's do some examples. All right, number one. All right, the example, and if you printed this out, you would actually have this would be printed out. This angle is 43 degrees. This angle is 57 degrees. And we know that this side over here, they call that A. So this would be lowercase b, lowercase c. And this side they give us is 4.56. So if this was a right triangle, you would already know how to solve it. but it's not a right triangle. It's an oblique triangle. So we can't use Pythagorean theorem because it's not an oblique triangle. But we can use some of the things that we have learned. For example, we are solving this triangle, which means we're going to have to find out angle B, side C, and side B lengths. We still can use some of the things that we did when we were solving right triangles. So hopefully, well, let's talk about what kind of triangle this is first. Notice we have a side, and an angle, and a side. See how they're connected? Like from here to here to here. So that is solving, I'll just put this right here. This is solving SSA. And we always, I'm sorry, I did that wrong. It was angle, side. So it's actually side, it's angle, side, or side, angle. It means the same. It means the same way. You can do it however you like it. This is how our book typically writes it, and most books write it. Rather than AAS, they usually do SAA. And this works. Side, angle. Okay? So the first thing I would do is find that angle. Whether the angle is a right triangle, or the triangle is a right triangle, or the triangle is an oblique triangle, all three angles have to add up to what? 180 degrees. So adding these two together, that would be 100. And so subtracting from 180. So we've already taken care of one thing. We know that that angle is 80. Now, how can we find, these? We cannot use Pythagorean theorem because it's not a right triangle. So we have to use, right here, law of sines. So what do we know all the angles, so we can just pick whatever we want. So let's just start with this one. A is to sine A. So 4.56 is to the sine of 43 degrees as, now it doesn't really matter which way would you like, which one you want to solve. We'll just go for B. B over sine of 80 degrees. So to solve this, we typically just use the cross products. Okay. So B sine of 43 degrees equals 4.56 times the sine of 80 degrees. Divide both sides by the sine of 43 degrees. Cancel, and that's the value of B. And this is when you get your calculator, which I've got mine right here. You get your calculator. Sorry about that. Forgot to bring it over here with me. And you're just literally going to put this in your calculator. 4.56 times the sine of 80 degrees. You could go ahead and say equal, or then you can just divide. Either way. But the one thing you got to make sure of, you're in the right mode. So go to your mode and make sure you are in degree mode. See, I was in radian mode, so I have to change that. There we go. Now I'm in degree mode. So you're just going to enter this in your calculator. Sine of 80 degrees divided by the sine of 43 degrees. And what you will find, okay, that is not the right answer. I don't know what I did. Hold on just a minute. Okay, I'm in the right mode. Let's try it again. Because I've already done it, and I should be getting, this is for B. We should be getting 6.6. Let me use the pink one so that they kind of match. And it's approximately. So on these, whatever's given to you is given to you. But when you are finding the side lengths, we typically round to the nearest tenth. Okay, we round to the nearest tenth. All right. So now we will try to get the last one, the C. So we can, first of all, let me say something. Remember, you don't want to use a number that you rounded off. I will admit, there are sometimes you have no choice. but you can at least take it out, like say 4 decimal places or something like that. But you want to round this to the nearest 10th. So we're not going to use this because that's rounded. We'll use this. This is exact. This was given to you. We'll go back and use that again. So 4.56 is to the sine of 43 degrees. And then now we're going to find this. So this is 57 degrees. C is to the sine of 57 degrees. Make that look better. Okay? And then you're going to do the same thing. You're going to cross multiply. So we have 4, let's see, let me start with this one. C times the sine of 43 degrees equals 4.56 times the sine of 57 degrees. And then divide by the sine of 43 degrees. So all you're going to have to do is put this in your calculator, and you should get 5.6. So you have solved the oblique triangle by finding the measurements that were missing, the one angle and the 2 sides. Okay? Now, if you print the paper, I actually have another example like this one. Okay? Let's try a different one. Here we go. Okay, this angle, this time instead of using ABC, I've got DEF. So we've got E, this is 35 degrees. So this will be lowercase e, which I actually already know is 25. That's given to us, 25. Okay, and this is D, we don't know. And this one is F, we don't know. But we do know this F is 102 degrees. And then we don't know angle D. All right, so you basically, if you have an, where it is? I guess oh, here it is. SAA, side angle, you just go for it. All right, so we have that. Side, angle. They're right in a row. They're all connecting. Side, angle. So the first thing I would do, like we did last time, is add these two together, subtract from 180. So that would be what, 137 from 180, so 43. So that's the first thing. Just add these two, subtract from 180. Good old triangle sum theorem. All right, and then we can start doing what we were doing before. We cannot use Pythagorean theorem. It's not a right triangle, okay? No 90-degree angle. So you can use this law of sines. It's called the law of sines. All right, so what do we know here? We know the e's. So we can say 25 over the sine of 35 degrees. And then we could just pick whichever one we want. So we'll do D over the sine of 43 degrees. All right, so once again, we're going to do cross products. Or you can solve it however you want to solve it. To me, that's the easiest. All right, so D sine of 35 degrees equals 25 sine of 43 degrees. Divide both sides by the sine of 35 degrees. Gone. And it's not going to come out even. And what your book, your assignment is having you do is round to the nearest 10th. So the D turns out to be, when you put all that in your calculator, again, make sure you're in degree mode, you should get 29.7. Okay, so D is approximately 29.7 And then do the same thing to find the other one. So we'll start with this combination because this was given to us. It's not rounded off, so we're going to use that. 25 over the sine of 35 degrees. And then we got to find F, side F. So F over the sine of 102 degrees. Okay? And then again, we're going to do the cross products. There we go. So F sine of 35 degrees equals 25 sine 102 degrees. And then divide both sides by the sine of 35 degrees. Whoopsie, gotta put the sign there. All right, so that cancels out. So F, again, you're just gonna put that in your calculator, and that turns out to be approximately 42.6. So we have solved the oblique triangle by using the law of sines. Now these two examples were side angle angle, okay? We're gonna learn one other one. This was actually Roman numeral number, that was Roman numeral 1. This was Roman numeral number 2. Now we're gonna go to Roman numeral number 3, okay? All right, let me erase this. And they are going to be oblique triangles again, but they're not going to be angle, angle, side, or side, angle, angle. These that we're going to be doing are angle, side, angle. All right, so Roman numeral number 3. Let me just erase that. Okay, Roman numeral number 3. This one is going to be solving angle, side, angle triangles, okay? And again, the only way to do that is using the law of sines. All right, the first thing, I'm only going to do one example for this one because you kind of get it now. All right, so we've got JKL. JKL. So this is lowercase l, K, lowercase l, and lowercase j. Okay? What we are given is 39 degrees is the angle K, measure of angle K. 73 degrees, sorry, make that look a little better. 73 degrees is the measure of angle J, and we don't know L, we don't know J, we don't know K. So what we are given is L, 14. So this one is not side, angle, angle. Because this is a side, it would be angle, angle. That's not what this is. This is angle, side, angle. And we'll have a deeper discussion next week on going back to geometry. The theorems that you could prove were the same, you know, that the angles were the same. So you had SSS, ASS, you know, all those different ones that you could prove. So, but we're just taking, right now, today, we're just learning the law of sines, okay? All right, so this one, angle, side, angle. Angle, side, angle. But you're gonna approach it the exact same way. The first thing you can do is find the angle L. So 39 plus 73, what would that be? 112? Yeah, 112 degrees. So subtract that from 180 degrees, and what do you get? 68 degrees. So we did the same thing. We found the missing angle first. Now we can use the law of sines to get the other two sides. So 14, that side L, is to the sine of 68 degrees. So you can just find whichever one you want. I'll just do the K over the sine of 39 degrees. And when I'm actually teaching this in the classroom, I would have you do this one by yourself just to make sure you got this, but can't really do that, so I'm just going to get it done. K sine of 68 degrees equals 14 the sine of 39 degrees. Divide both sides by the sine of 68 degrees. Cancels out. All right, so you're going to, put this in your calculator. 14 times the sine of 37 divided by that sine of 68 degrees. And you should get, let's see, K should be 9.5. Remember, we're rounding to the nearest tenth. So approximately 9.5. And that is K. Okay, and then J, find that one. We'll start out with we're not going to use this. That's a rounded number. Don't use that one, okay? Try to use something that's given, that is exact. So this one is exact. So 14 over the sine of 68 degrees equals, what are we missing? We're missing J. So J over the sine of 73 degrees. So once again, we're going to do cross products. Okay. So J times the sine of 68 degrees equals this cross product, 4 times the sine of 73 degrees. And then just divide by the sine of 68 degrees. So J is approximately, I've already done it, 14.4. All right, so this is approximately 14.4. Here, actually, let me just do that in pink, because this is what we found. We found these as our answers. Okay? All right, so this is all about the law of sines. We will have another lesson on the law of sines, and that will be the next video. So, okay? All right, so study for your test for Friday. Do get that done. Worry about that, and then maybe during the weekend you can do this. Okay? All right, have a good one.